These are the notes for thermal energy, which you can find on pages 23 and 24 in your packet if you're following along that way. So we're going to be using energy bar charts in these notes and on this worksheet. So here's an example problem that would use an energy bar chart. It says that a 1,000 kilogram vehicle is traveling at 40 meters per second and crashes into a wall. All of the energy is converted into heat. What is the change in temperature? And so here we have a car that is moving at the beginning, and so it has kinetic energy, but then it crashes, so it doesn't have any kinetic energy at the end, but instead it says that all of its energy is converted to heat, which we're going to call thermal energy, kind of like dissipated energy, which we've talked about in the past. So just a real quick review. If we look at the energy skate park simulation that we started in Unit 2, we had thermal energy, and that was similar to dissipated energy, and it was energy that is found in an object heating up due to friction, right? And so now that we have an equation that can actually solve for specific values, including thermal energy, we can use this as part of our energy bar charts as well. So back to the example with the car. It starts with kinetic energy and it ends with thermal energy. So our equation would just be that those two energies are equal to each other, that the amount of kinetic energy at the beginning of the situation was equal to the thermal energy at the end. Then we need to start looking at the values in the problem and seeing what variables they go with. This will be based on the units. So the 1,000 kilograms is a mass because kilograms are a unit of mass. The velocity of the car was 40 meters per second. The specific heat of the vehicle is 490 joules per kilogram degree Celsius. The change in temperature we do not know yet. And so what we can do is we can look at the energy equation from the energy bar charts, and then we can substitute each equation with, or each type of energy with the equation used to solve for that type of energy. So kinetic energy is equal to 1/2 mv squared, and thermal energy is equal to mass times specific heat times change in temperature. After this, we can start plugging in all the values that we have from the problem into those equations. And so here's what all of those values look like before they are solved for. On the left, we have 800,000 joules. And then on the right, we're going to multiply these first two numbers, but then leave the variable as a letter. We can then divide both sides, this side and this side, by 490,000 in order to get the change in temperature alone, which is 1.63 degrees Celsius. For the second example, we have cooking oil that's initially at 25 degrees Celsius, and it's heated on a stove up to 100 degrees Celsius. During this process, the stove does 200,000 joules of work on the oil. What is the mass of the oil? And so our energy bar chart would look like this. The oil had no specific type of energy beforehand, and then the stove, or the hot plate, gives energy to the oil in the form of thermal energy. In our problem, we see that the stove does 200,000 joules of work. We don't know the mass of the cooking oil. The specific heat of the cooking oil is stated early in the problem. And then here it says that the change in temperature is 75 degrees Celsius, which we don't see actually in the wording of the problem. But the oil goes from 25 degrees Celsius up to 100. And so that's a change. It goes up 75 degrees Celsius in temperature. So our energy equation based on the bar chart is the oil starts out with no energy, and then when we add the work from the hot plate, we end up with thermal. So 0 plus W equals E therm. We can then plug in any equations that we know. We don't have an equation for work, but we do have an equation for thermal energy. And so if we plug those in, we can then start to put numbers for each of these variables. We have the work, we have the specific heat and the change in temperature. And so now what we're going to do is solve for mass. First, we're going to multiply the two numbers on the right side of the equation, and then we'll be able to divide both sides by 125,250 to get that the mass of the cooking oil was 1.6 kilograms. Thank you for watching.